Well, as you heat up, and then you will see at all these temperatures, and it will go higher from 100 degree, and then at the same time you write down the speed, and time 200 degree the speed, and then you will see as we go up the distribution will change over here on the side, and enter your distribution in your laptop, and or sketch it or take a snapshot on this and put it insert nicely, and then we will insert another column because we want to study kinetic energy, which is actually the speed squared average. So then we will do this Excel. We enter the temperature and we enter the speed, and then calculate the squares. Okay, that's actually proportional to kinetic energy apart from a factor. So we just do a quantitative study instead of really mathematics study. We want to know how the trend is. So then we want to square the speed. To do that, here's the Excel trick. So you click this cell and put it over here and put equal. So which means you want some kind of function calculation. Now equal what? Equal this one, and then squared, and then probably you can do this and squared and press enter. So you see that number 263 squared is that, and you can check with the calculator. But at the same time you want to do this all to corresponding columns, and the same procedure is carried out row by row, and you just click the little corner, the little square on the corner, and let's drag it all the way down. Boom. Then you will have all these calculated instead of pressing the calculator. Now you want to make a plot of temperature versus speed, and and then you will see how it goes. And then this is the Excel trick. Insert, and I just use scattered graph, and then scattered graph. Of course, you will choose this and make Now, if you have multiple data you want to select to plot, usually the leftmost column is to be on a horizontal axis. So we want to plot the speed. So you click here, the temperature, and then hold the control key, and then that one, and you select this two, and then go over here and insert the scatter plot. You see, now on the bottom, on the up is speed, and now you see the speed is increasing slowly with temperature, obviously. But it's not it's a square root. It's not a straight line, but increase slowly, kind of slowly, the higher temperature. So that's the speed, right? And I want you to plot both. Now you plot speed squared, which is actually kinetic energy, and then you do another plot. Now you say, okay, here, and then hold the control key, select this one instead, and then you insert another plot, which is the kinetic energy and then speed squared, apart from some factors, and which we are not interested in at this moment, and scatter plot. Look, here's another plot. So let's compare. So this one is speed squared, and then you will have this. So from mathematics, you will see if you just plot speed, so it was also temperature is also from 0 to 3000, 0 to 2000. But if you plot speed, we just want to look at the curve shape, and it's like a square root going like curve down, and in the sense that the higher temperature, the speed is not going up, still going up, but not as much. But then if you plot square, and which is half mv squared, that's kinetic energy, and proportional to it, and then you see it's straight line. Whenever mathematically a straight line, we call it linear. It means the temperature is tied directly or proportional to the speed squared, and is proportional to the kinetic energy. That's the whole point. And you recognize you plot the temperature, so this is the speed and squared, and go with the straight line. The temperature goes up, the speed, average speed is going up, then that's the kinetic energy. All right.